Okay, so we're trying to take the integral of x cubed times the square root of x squared plus 1 dx. So the first thing we want to do is we look at it and we notice we could do a nice little substitution for x squared plus 1 right here. So u is equal to x squared plus 1 is our first step here. So when we have this, we want to take the derivative of it, and we call it du, and then the derivative of this would just be 2x dx. Now, if we look at this though, we notice that we don't have a 2 anywhere in here, but we do have an x at least. We have an x cubed really, but at least an x. So we want to move this 2 over by multiplying both sides to 1/1/2. So if I multiply this by 1/2 and I multiply this by 1/2, these will eliminate and I get 1/2 du is equal to x dx. Now I at least have an x and I have my dx there. So this substitution will work. Now it might not be easy to see it, but you could rewrite it like this. You could rewrite it as x times x squared, which is the same thing as saying x cubed, and then times the square root of that x squared plus 1 and then dx. Now when I make the substitution, now I'm going to go ahead and rewrite it that way. So I'm going to write it as x squared and then the square root of x squared plus 1, we let u equal that. So we're going to write it as u, and then also that x. You might be wondering why I don't have the x in this one. It's because our du, if you remember right, and also our 1/2 should be here because the 1/2 du. So the reason why it wasn't there is because we let that du equal x dx. So x dx is now known as du. Now from here, we can't really integrate this because we have two variables, two different ones. We can't do that. We're trying to integrate it with respect to u. So what that means is I got to go back up here and I got to solve for my x squared right there. And how I do that is I go to this original substitution and I'm going to subtract 1. So both sides. So you get u minus 1 is equal to x squared. Now I can make a substitution here, and now they're all in terms of u. So when I do that, I rewrite it as this. So where I have the x squared, I'm going to write that u minus 1. So I have u minus 1 times the square root of u and du. So what's going to happen now is now I'm going to distribute this, and so we know that this u to the 1, the square root of u, we could rewrite it as u to the 1/2 as well. So that's how I'm going to write it. So what happens is I'll distribute it, and you end up getting 1/2 the integral of u. So this is to the 1 power. So if you add a 1 plus a 1/2, you get a 3/2. And then minus that u to the 1/2 times 1 would just be u to the 1/2 du. Now I can integrate this. So when you integrate it, you're going to add 1 power, right? So I'll just say a 2 over 2. Kind of ugly, but you can see that one better. But when you do that, you end up getting u to the 5/2, and so you have to flip it and bring that 5/2, and when you flip it, it becomes a 2/5. So you have 2/5 u to the 5/2, and then minus, when you add this, you get 3/2, but again, you flip that, so 2/3 u to the 3/2, and so that plus c. So now we have, in terms of u, our u we said was x squared plus 1. So now I'm just going to write it in terms of that. And so this would be typically a correct form of writing the answer, but if you wanted to go a step further, you could by distributing the 1/2, and you get it to simplify just a little more. So when you do that, the 2's will cancel when you distribute there, so you actually have 1/5 x squared plus 1 to the 5/2 power minus 2/3. So that 1/2 will get distributed to the 2/3 as well. So the 2's will cancel and you get minus 1/3 x squared plus 1 to the 3/2 and then plus c. And that will be your answer. Alright, thanks. Bye.